Okay, this is in the middle of explaining the Rambam, perek 17, hachodesh, halacha dalet. We're trying to explain the difference between when the moon is in the area of 270 to 90 or from 90 to 270. So we'll explain first from the area from 270 to 90, that is, let's say, 0. Let's take a look here. 0, take a look here, it says Shkias Majva Shamayim. Means the equator, the celestial equator, is Shekeah. So it shows each 5 degrees of the celestial equator. 5, 10, the first 5. We start from Tele, that's 0, 5, 10. And as we said previously, each degree takes 4 minutes. So, for example, from 0 to 5 is 20 minutes. Another 20 minutes. And this shows, this axis shows how much degrees of the ecliptic has set during that period. So now, by the area, here we can see it's very slow. For example, 15, that's hour, he only set about 12 degrees. Let's assume, we'll take an example. Let's take an example that the sun is at 0 and the moon is at 20. We saw in the Rambam that if we are in the time of 270 to 90, we have no problem whatsoever. Why? Because it takes 20, you look at here, 20, this 25, 25 means 25 times 4, that's 100 minutes, hour and 20 minutes. Since it takes so long to set, so we are not worried. We say, listen, we have the moon being a nice size, it's 20 degrees separated. But if it will be very fast till it was set, so we have a problem, because from sunset to moonset is so fast, and that means that we wouldn't have enough time but here that's not the problem. You have 100 minutes. So it's going to be quite dark already. Imagine the darkness depends on the minutes. It will be quite dark already when the moon is about to set. A long time passed already. This is why when the moon is in the area from 270 to 90, that whole area, it takes a long time for the ecliptic to set, and that gives us more time that it gets quite dark, and since it gets quite dark, we're not so bothered by the fact that the moon is small in size. So the Yesod is, in this area, the ecliptic sets slow. Take a look, I'll give you some nice, here you can see this, it's a nice big chart. It goes Shkias Talel, Unas Shkias Majve, Hanikra Erechavi. It goes all the way from 0, you can use this chart from 0 to 180. And if somebody would ask, how long does it take from the second part? This chart only is from 0 to 180. Answer is, we look here. Let's see, somebody asks from 180 Take a look here. Let's take 170, 180. These two boxes. So the 10 degrees from 170 to 180. Let's see here the difference in. Wow. Look what's going on. Look how much set from 170 to 180. That's 40 minutes. 170 to 180 is 40 minutes. It's 10 degrees. But guess how much degrees of the ecliptic have set? From 166 or 167 till 180. Huge part. This graph is made in such a way that we don't need to write everything from you don't need to show everything from 0 to 1 to 360. The way it works is that it's sufficient if we have here 0 to 180, and then we know automatically 180 to 360. The way to do it is we understand that it works with 360 minus x, as we just showed now, that 170 to 180 takes the same time, in that amount of time, the same part of the ecliptic sets than from 180 to 190. So everything here you can use as a reflection. If you want to know 360, anything from 180 to 360, you take 360 minus x. So if you want to know how much it takes to set from 180 till to 210, that's the same like from 150 to 180. 30 degrees this way, 30 degrees the other way. That's the idea of this. So we only have the chart, mathematically it's equivalent. It's like the point of 180 and of 0 are both, everything there gets doubled. So let's say here also 0, 10 and 360 and 350, 360 both in this only very small part of the ecliptic sets from about 7 degrees. 7 degrees this way or 7 degrees the other way. And you see the chart. Okay, let me go now. So this is the general understanding here. The Rambam, it gives us this, and we'll get back to this soon. The concept is well understood. It's basically timing. Certain parts of the ecliptic take a longer time to set, certain shorter time. If it takes a longer time to set, you have a better chance to see the moon, although it's small. This is summing it up in a moment. Now let's take a look at this. This goes, it's very similar to before, just using the degrees of celestial equator, degrees of the ecliptic, same concept. And here you see the higher degrees in this area, 120, 180. It's like zooming in into a certain area of the certain areas of the celestial equator. Okay, let's take a look at another graph here. Okay, this is a new subject. This subject describes Netias Hamilka. What does this mean? Inclination of ecliptic dependent on which degree of celestial equator is on the horizon. We explained in the previous video that these two things are related because it's all solved with one formula. Namely, we have here a point of the celestial equator that's right now on the horizon of Eretz Yisrael. At the point be 20, 30, and so on. Two things are happening now. First of all, we have certain amount of degrees of the ecliptic that have set. When these 20 degrees have set, and that we explained that sometimes more, sometimes less degrees of the ecliptic have set, depending on which degrees of the celestial equator we're referring to. From 0 to 20, we say it's slow, not so many, and from 180 to 200, more degrees are setting. The second thing that's dependent on this is at each given moment when a certain part of the celestial equator is hitting the horizon, we can figure out what is the inclination of the ecliptic at that time. As we see here, in the beginning, 0, this is 0, 10, 20, 30, it's divided by 100, 1, 2, 3, 4. That's how it's divided into 4 parts. So, 0, when the celestial equator is 0 and the ecliptic is also 0, it's 83, it's the highest inclination. And the lowest inclination of the ecliptic is by 180. Meznaim. The Meznaim is on the horizon. This doesn't measure with Meznaim. This measures degrees of celestial equator. The reason is because mathematically it's easier to calculate. So we have to somehow first find out what degree of celestial equator is on the horizon. And we can do that through the previous chart. At any given degree of celestial equator on the horizon, you can know what the inclination of the ecliptic is. As you see, it varies from 80 to 30, 35, something like that. Each one is 5 degrees, so it's less than 34. Okay. This, I think we can conclude. Let me just see if I want to show one more thing. On the next tape, we'll explain why it's important for the next piece of Rambam, for Hey, Vav, Zayin, to know the inclination of the ecliptic. Okay, this we'll explain later. So I want to go away from this. This is what we showed already many times. This is the triangle that we solve. This is the horizon, CB. CA is the ecliptic degrees, and AB is the celestial equator. We want to find this one, AC, or we call it small b, how much degrees of the ecliptic have set. If we know AB, we know celestial equator, and here we see that it's little. This degree is more than that. This shows the picture when it's in the area of 270 to 90. Also, imagine to extend this angle here. We want to know this angle. You know this one actually, you know this one also. So 180 minus this. That will be the Netias Hamilka. When this moment that we know which part touches the horizon of the celestial equator, what will be the inclination of the ecliptic towards the horizon?